In this video, I'll demonstrate how you can connect two different representations of trigonometric functions. One is using the unit circle, and the other is graphing these functions in the form, for example, f of x equals sine x. So here we have the unit circle sitting at the origin, and we have a segment on the x-axis whose length is equal to the circumference of this circle, 2 pi. I'm going to start by placing a point onto this orange segment. I'll tap the point tool, and when I do, I see a preview of the point that I'm about to place. Notice that the point is glowing. That indicates that the point is ready to be placed. I want to put the point onto this orange segment, so I'll tap, and now this point is attached to the segment. And let's use the label tool to give that point a name, point A. Now I'm going to use the animate tool, so I'll tap that tool, and I see a preview of a point and a button that will animate that point. I want to animate point A so that it moves from left to right along the segment, so I'll tap point A to attach these 2 points. And now my tool is done. When I tap animate point, we see that point A moves along the segment from left to right. And if I tap the button again, my point stops moving. So now I'll drag it just a little bit back to the left. To continue, I'd like to place a point on this circle, and the location of the point on this circle should mirror the location of point A along this segment. So I'd like to measure the location of point A on this segment, and I'll use the abscissa tool, which will measure the x-coordinate of point A to do so. So I'll tap the abscissa tool, and I see a preview of a point and the point's x-coordinate. I want the x-coordinate of point A, so I'll tap to merge point B to point A. And now I'm done. I see the location of point A given by its x-coordinate, which is 2.65. And when I drag point A, I see that the location ranges from 0 all the way to 6.28, or 2 pi. So I'd like to represent this same location of point A on the segment as a point on this circle. And to do that, what I'm going to do is to rotate this point here at 1, 0 by the location of point A, 2.51, as 2.51 radians. So here I've tapped the rotate tool, and I see a preview of a point that I'm going to rotate. That's the point that's glowing. I see the center of my rotation, I see the angle of my rotation, and I see the result of rotating that point. So right now the point that I want to rotate is glowing. So what point do I want to rotate here in my construction? Well, that's the point at 1, 0. So I'll tap that. Next, I need to indicate where is the center of my rotation. Well, that's going to be the origin. So I'll tap the origin. And finally, I need to indicate by how much I am going to rotate this point. Well, I want to rotate it by 2.51 radians. So I'll tap 2.51 to merge these two values together. So now I have this point that I've rotated. And notice that when I drag point A, this point starts at 1, 0 when point A is at 0, 0, and it travels all the way around the circle, making it once around all 2 pi when A gets to the right endpoint of this orange segment. So this allows me to take this motion of point A along this segment and transfer it to this circular motion around the unit circle. And while we're at it, let's label this point here, and why don't we call it point P. So to continue with my quest to create the two different representations of the sine function, let me now measure the ordinate of point P. So when I tap ordinate, I see a point here that's glowing, and I see its y-coordinate. And since I want to find the y-coordinate of point P, I'll tap point P. So here now, as I drag point A, point P moves, and notice that y sub P is updated as I drag A. So to continue now, I am going to plot the value of y sub P directly above point A. And to do that, I'm going to use the plot as xy tool. When I tap that, I see that I need to attach this x value to something in my sketch, as well as the y value. Well, the x value that I'm creating is the x value of point A. So I'll tap x sub A to merge those together. And the y value of this point that I'm plotting is y sub P. So I'll tap that. And here is that point that I've just created. Its x-coordinate is the x value of point A, and its y value is the y value of point P. You can imagine a vertical line extending up from point A to this point, and then a horizontal line connecting to point P. So as I move point A, notice that this point moves in relation to point P, always maintaining the same y value as point P. And what I've created here is a way to take the circular motion of point P, and in particular the y value of P, and graft it on here to the movement of point A, so that as point A moves, we are tracing the height of point P. And that's the sine function. So to actually trace this point, I will tap the trace widget, I will tap the point, and now when I tap on animate point, we see that this point is tracing the sine function as point P is moving around the circle and as point A is moving from left to right. I can tap to stop this motion. I can erase traces if I like. And I might, if I want now, to also trace simultaneously the cosine. So to do that, I am going to use the abscissa tool to measure the x-coordinate of point P. And then, as before, I'm going to use the plot as xy tool. And this time I want my x value to be x sub A, as before, and the y value to be x sub P. That gives me this point here. To distinguish it from my other point, let's change its color. We'll make it blue. And let's trace it. So now let's watch and see if we trace both the sine and cosine graphs at the same time. And there we have it.